Alright guys, welcome to RC Mojo. This week we're going to get the P407 running. After lots of waiting around, I finally have a steering servo. It's a generic 20 kilogram one that comes with a nice metal servo arm. Nothing special, but it should do the trick. For the receiver, well, I'm still waiting for the one to turn up in the post, so I've done something I don't like doing, and borrowed this one from the Tamiya TXT1 camera truck. I try and avoid stealing bits from other models, as it quickly turns into a bit of a habit, and before you know it, you don't have any trucks actually running. At least this one's the same receiver as the one I'm planning to fit anyway, so eventually one of the new ones will go back in the TXT1. It's got 6 channels, so we'll have steering, throttle, gear shift on the first 3, leaving the second 3 free to control the lights. If we really needed to, there's also an 8-channel receiver we could use instead, but it is quite a bit bigger. You can find these servos on eBay for about 15 quid. Visually they're the same as the Power HD branded ones. You know you have the right one because it comes with one of these cheap aluminium arms. It's probably not the best servo in the world, but I've heard from a couple of people they do the job, so I thought I'd give one a try. The servo also comes with the usual bag of plastic arms, grommets and ferrules, mostly useful on model planes rather than trucks of course, but to be honest I tend to stick to known brand names on things that fly, especially if they weigh a bit. On a truck, if they fail, usually the worst that's going to happen is you go home early. On a plane or heli, the model could crash into something or someone, causing damage. Right, to swap the steering servo we'll need access to the servos on the chassis. It would be nice if all we needed to do was remove an easily accessible lid and pop the servos out. But no, this is based on an old Tamiya, so to access the servos we should really remove the whole radio box from the chassis. But we can cheat the system a little bit. It's not impossible to get at the 4 screws that attach the base plate to the radio box. The front 2 are at a bit of an angle, so you really need a good screwdriver or ball-ended key to get them undone. With the screws out, you can lift the floor away from the box and proceed to fight it past the leaf spring mounts. It's a really tight fit and does require a bit of force and much jiggling. Just be careful and you should be able to get it out. Now we have fairly good access to the servo. We could also prop the drive shaft off the axle to improve things even more. And for the sake of the video, I probably should have. The servo that we're swapping is directly behind the universal joint from your point of view. Anyway, we'll need to remove the screw in the centre of the servo saver first to free up the linkage. The servo that's in there at the moment has plastic gears, so we used a self-tapper. When we reinstall it, we'll need a suitable M3 screw. And yes, we're going to reuse the stock servo saver just for now, so we can giggle at just how bad the stock steering really is. On the servo lugs we have 4 cap head screws to remove. Stock, the manual wanted us to use 2 self-tappers, but we replaced them with the M3 cap heads and tapped the plastic, which really does make it so much nicer to do the swap. With the screws out, the servo can be lifted from the box. It's not plugged into anything, so the lead just pulls straight through. To set up the new servo, we'd either need to connect up a radio with all the trim set to neutral, or we can just use a servo tester. Just like when we first built the truck, we need to make sure the new servo is properly centered before we transfer the servo saver's boss. We want to fit it so the lug that the servo saver spring clips over is at the top as we hold the servo. Now we can start putting it all back together, first by feeding the servo lead up inside the radio compartment, then dropping the servo onto its servo rails. Reinstall the 4 mounting screws, or the 2 self-tappers if you've got the ready-to-run truck, pop the servo saver on its boss, and screw in an M3x8, replacing the stock self-tapper. It's worth noting, using visions from the future, the servo saver screw will come loose after approximately 1 hour of running, so if you're planning to keep this set up, a spot or thread lock might be in order. Now all we do is slide the floor back through the chassis, which does require some very mild swearing, and then we reinstall the 4 screws to attach it to the box. Okay then, so that's the servo swapped. Something that we wouldn't have had to do if the servo I originally ordered came on time. But there we go, things go missing sometimes. And to be honest, I'm always slightly amazed with how much stuff gets shipped globally, how rare it is to have problems. Radio next then, and at the back of the radio box is a nice little lid with a single screw holding it on. If only they'd come up with something similar for access to the servos. With the screw removed, we just lift the lid, give it a bit of a wiggle, and off it comes, revealing the servo leads. For the ESC, not surprisingly, we have yet another Hobbywing WP1080. An excellent ESC, it's got a nice selection of programmable options, a good robust 6V BEC, and you can set the drive frequency high enough that there's no motor whine at low speed. Also, the best bit is you can pick them up for well under 40 quid. Now I'm going to fit the ESC in the radio box, which isn't really ventilated, but I'm not worried, as I often use a WP1080 in a G-made GOM rock bouncer with a 27-turn motor on the 3S, and it doesn't really generate enough heat to detect by finger. This truck with a higher turn 550 on 2S won't be stressing the ESC at all. In the manual they have the motor wires and the battery wires running through the radio box and up through a hole under the battery tray. For the motor wires, that seems like a good plan, but for the battery I think we can do better. To the right of the radio area there's a notch in the wall. If we can get the battery wires through it, it'll make for a much neater install. They're a bit tight in there, but they do just about fit, even with the lid on. It brings the battery connectors neatly out to the battery. We might end up having to open the hole out though, just a little bit, as it is pinching the insulation, but it'll do for now. The motor wires are a bit more tricky. We'll need to remove the 4 screws attaching the battery tray to the box, and remove it so we can get at the hole. The wires on the ESC are already quite long, but they'll only just reach to the hole, and the stock motor wires aren't quite long enough to comfortably reach. What we'll do then is replace the motor wires with some nice new wire so we can make them just the right length, and we will use some nice fancy gold connectors to connect it all up and still allow for things to be removed later. Now, I'm not going to show the soldering this time, as to be quite honest, it's unimaginably awkward trying to solder with a camera in your face and reaching around a tripod. So today we'll just cut to the next stage. On the motor then, we've got the male connectors fitted, and on the ESC we've got the females. Before we can plug them in though, we'll need to feed the motor wires through the radio box and through the square hole, which is easier said than done. We could take the bottom off the radio box again, but that was a bit of a faff. It's easier, but still a bit of a pain to fiddle with the wires until you can see them through the hole. Then try and grab them with a pair of tweezers and fish them out. Now we can connect up the wires. We've got yellow going to the positive terminal on the motor, so it should just be a case of yellow to yellow and blue to blue. You never know though, some models like the TRX4 do run the motor backwards. To keep the motor wires tidy and out of trouble, we'll use a couple of the black zip ties to help guide the wires along the chassis rail. It might feel like a bit of a chore, but keeping the wiring tidy does avoid problems later, plus it does look a lot better. Before we go any further, we should check to see if the electronics actually work and if we need to change anything. We'll connect the steering servo to channel 1 and the ESC to channel 2, then connect a battery. With the transmitter switched on, we can hit the ESC's power button and see what happens. Well, it beeped, so it sounds like it's all good to go. We just need to test the throttle direction to see which way it actually runs. Right, so when we pull the trigger, the truck rolls backwards. The question is that the motor wired in reverse, or does the transmitter throttle direction need to be changed? On the face of it, it does seem difficult to work out which. Now sometimes ESCs go faster forward and reverse, but not always. Now the WP1080 comes with a programming card that lets us tweak various settings. We're going to fiddle with item 1, the running mode. By default it's set to forward reverse. We're going to change it to forward brake, in effect disabling reverse altogether. To connect the programming card, the ESC comes with a socket-to-socket cable that connects to a 3-pin header on the top of the ESC. The other end connects to the top of the programming card. Turn the ESC back on, and instead of going through its normal set of beeps, the programming card powers up. It's already set to item 1, so we just need to change the value to 1 and press OK to save it. Turn off the ESC, unplug the programmer, then with the transmitter powered up, we can turn the ESC back on. This time the truck will only do what the ESC considers forward. If we pull the trigger and the model goes backwards, the motor wires need to be swapped. And if the transmitter's backwards, the truck will roll forwards when we push the trigger away. And there we go, it's the transmitter that's backwards. If we turn off the ESC, we can go through the transmitter menus to reverse channel 2. Now we can get the programmer out again and reset item 1 back to value 3, forward and reverse. This time when we power up the ESC normally and test it, the truck goes the right way. And we know it's all running as it should. Next we can pop the battery tray back on the radio box, installing the 4 screws, making sure we don't trap any motor wires, and now that just leaves sticking the ESC and receiver down in the box at the back. The ESC is going to sit on the right hand side, so the battery leads go through the slot. We'll also need the cable for the power button and the programming card to go through there too. The receiver's a bit more tricky. Now ideally it would be best if we could get the antenna up and out of the way of all the metal parts on the chassis, shocks and even the servos. The metal bits will shadow the signal, reducing the range. For a crawler it's not too much of an issue though, but more is always better. We could poke the antenna up through the hole in the box lid that's meant for a switch, but it's going to look a bit silly. Usually I'd have the antenna vertical in the back corner of the cab, but with the receiver all the way at the back of the truck, that's not going to happen. I think the best we're going to be able to do is run it horizontally along the servo area. There's only 2 servos in there, and they're on the far side. It's far from ideal, but I think it's the best we can do. To get the antenna out, we're going to need to cut a slot for it. First we'll use a hacksaw to make a guide slot, then use a round microfile to open it up and smooth out the edges. Before we stick the bits in, we need to carefully clean all the surfaces with some alcohol. If there's any oil or grease left, the servo tape will just fall off in no time. The cleaner everything is, the better. The ESC and receiver just get stuck down to the bottom of the box. There's so much space in there, there's not really much to worry about. For the antenna, I'm going to use another thin strip of tape just to keep it in place so it doesn't stress the coax where it leaves the box. Plug all the servo leads in and stow the excess wire nice and neatly. We just need to make sure that it can't fall back into the servo area and get caught up in the linkages. Pop the lid on the radio box and we're ready to see how it runs. It's not a bad idea to set the endpoints of the shift servo channel really low before powering up the truck, then increasing them so that they engage first and third. It saves overdriving the shift linkage, stressing out the gearbox and the servo. The gear shift generally works very well. Sometimes the dog clutches don't quite line up, but if you change the throttle a bit, they always just fall in. It's certainly no worse than Tamiya's 3 speeds, and the rest of the gear train runs really rather nicely. It sounds very smooth and quiet. I'm impressed. And that's about it for the build. I did try filming the ESC setup while out and about, but I found trying to show in video the results of the changes is quite difficult to get over. And I think part of the problem was I was doing it on grass. Perhaps somewhere with more consistent grip might be better. Anyway, that's it from this video, but I've also uploaded a little video of its first test run. No crawling as such, just a bit of a bimble around the woods. With open diffs and a stiff suspension, it does quite well. And yes, the steering is just as bad as you might imagine. I'll link that video in somewhere, but in the meantime, thanks for watching, like if you liked, subscribe if you haven't, and leave a comment if there's something on your mind. Bye guys!